All right, all right, all right. So we have this question, comes from the textbook scans, I believe chapter 6 of the Prentice Hall textbook, pharmacy math. And we are looking at a question that has to do with concentrations and dilutions, right? So right off the bat, you may think that we're going down a dark and dangerous road. Let me put your mind at ease. You're wrong. We're not going there right now. You know what I'm talking about. That allegation grid, the tic-tac-toe, witch graphs. We're not doing that. We don't have to. Completely unnecessary and called for in this problem. And there's a hint right off the bat as to why. This right here is the question. How much acres? So what's left is the information that they're giving us. And the information that they're giving us, they only give us one strength. Right? We're starting with a 20% solution. We're going to be setting up an allegation grid. We're trying to find a proportionate ratio of two different strengths that we're mixing together. Basically to increase the lower strength or dilute the higher strength. Meet in the middle somewhere. Okay, that's what that grid, that tic-tac-toe method is used for. Okay, is to find a proportionate ratio of the sum parts of the total volume of the new mixture. We don't have to do that because we can infer from the information that they gave us that we have a 20% solution and then something else. Doesn't matter what something else is. It could be water, syrup, alcohol, elixir, doesn't matter. Whatever it is, it's not drug. So we're taking this 500 ml solution, which is 20% drug, and we're mixing it with unknown amount of not a drug to get unknown total volume that is 8% drug. Okay. What we're going to do is we're going to tackle this piece by piece. Really not that scary. All you got to do is take your flashlight out in the wilderness, find the path. Path starts with the information that they gave us, right? So what do we know? Just from this part, we're can on. What do we know? Well, we know a lot. All right, this is actually a treasure trove of data that we can glean. We know that there's a base. We know that there's a diluent. We know that there's something, we'll call it the not a drug, that we're mixing this 500 ml 20% solution. Okay. What is the concentration strength of the not a drug? 0, right? Because it's not drug, it's something else. Okay. So we have our two strengths implicitly based on the fact that they only gave us one. That means the other one, they only give you one strength, and you're talking about dilution, right? That means that you're dealing with something that is 0% drug. Okay. So we know that. And we even know exactly how much drug there is. We do. There's 500 ml of the original 20% solution. Right? 20% of that is drug. That's what that means. That is the strength, the concentration of drug in that solution. This 500 ml is 20% drug, 80% not a drug, something else, whatever that solution was originally mixed with in the first place. Could be the same diluent, could be different. We don't really care. We have 500 ml, of which 20% is drug. So that means we know the exact volume of drug that we have on hand. Oh, yes, we did. Because we know that to figure out a percentage of something, we're going to use a multiplication factor of that percent expressed as a decimal. Right? How do we express a percentage as a decimal? That can be a multiplication factor to figure out the percent of something. What is a percent? Percent is usually talking about a whole, right? One whole something, 100% of something, 1.00 something. Here, let's little smudge here. Over here. 100% is one whole something, right? So if we're going to convert from a percent back into a decimal, get rid of that lovely percent symbol, and we jump back in the other direction. 1, 2 spaces to the left, decimal point, 1.00. Okay? So the conversion factor is 1, talking 100% of something. Okay, we're talking 200% of something, we're doubling it. That would be a conversion factor of 2.0. But life's not that simple, so we have non-integer decimals, which means parts of wholes, right? So, say for instance, we want to talk about a quarter, right? 25%. So, how do we know that 25% of 100 is 25? Well, you know it because you know it. It's like, you should know it. If you don't know that, you should know that. But if we want to create a mathematical proof to visually confirm with ourselves what we know to be true, we can say that we have 100%. Okay? I want to say, what's 25% of it? So our multiplication factor is going to be 25 percentage, but expressed to the decimal. Instead of saying times 25%, that's not really how we do that. It is, but it's not how you put it in the calculator. Good. For depth of understanding, we're going to do it this way. Get rid of that 100%, that percent symbol. You're going to jump 2 spaces to the left. You're going to put decimal. Now, here in writing, you're going to want to put a 0. Why? Because it's easy to miss the little dot. At 0.25 could look like 25. Then you're multiplying 100 times 25. And you got 2,500. We don't want that. We want a much smaller number than 2,500. Okay. We are orders of magnitude up. So 100 times 0.25 or 0.25. Okay? And if we're multiplying something by 100, what are we doing? Adding 2 zeros to. Right? So just moving that decimal point right back where it was in the first place. Except without the percent. Cool. So we know that this system works. No, we convert from percentage with a percent symbol to a percent expressed as a decimal simply by that decimal point 2 spaces over to the left. Okay, that's how we do that. So we know that we have 500 ml in this bottle that the pharmacy has on hand. All they have in stock is a bottle of 20% solution. We have exactly 500 ml. So we have this amount that we're about to figure out of drug. That's it. All right. Pharmacy down the street can't loan us any. All the back orders, not going to be until next week. This is what we have to work with. It's the amount of drug that we have on hand, and then we're going to have on hand. Okay. This is an amount that we need to figure out. So that's all the drug we have to work with. We are going to take our 500 to find what 20% of that is. How do we do that again? Well, our multiplication factor is our percentage expressed as a decimal. Times. Now, for the purposes of writing, you always want to write the 0 before the decimal point. so that it is visually clear that there is a zero there, and that you're dealing with a sub-integer decimal amount, right? Just on the off chance that someone maybe has impaired vision and is not seeing that decimal point, or someone makes it too small. That could easily be mistaken for 500 times. We don't want that. So we are going to, when writing, put the zero. That brings me to another point. 20%, right? So we're moving 2 spaces over, eliminating the percent symbol on this side, replacing the decimal point on this side. We don't write 0.020. Why? Because we don't have to. Because we already know that it's a sub-integer decimal amount, right? We know it's less than 1 whole of something. We know it's less than 100%. So we have a 0 and a decimal here. This doesn't really serve any purpose. It's implied just by the 2 being in the tens column, that first space after the decimal point, that that's 20%. So that's our multiplication point. We don't need that trailing 0. It's redundant. No point writing it, no point putting it in the calculator. We don't want that extra 0. So 20% expressed to the decimal is this. 0.2 on the calculator, 0.2 when you're writing it down, times 5. Okay. And this is more math that, I'm sorry, maybe it's controversial. You should just know that. Okay, like you should know what 20% of 500 is. Really easy. Okay. At the very least, you should know what 20% of 100 is, right? 20% of 100 is 20. Cool. So if you have 5 of those hundreds, 5 of those 20s, here I'm going. All right, so if you don't believe me, you can put this into your calculator, take your starting volume of drug times strength percentage expressed to the decimal, 0.2, drum roll please. You got something completely different on your calculator? It's broken, or there was a user input error. If you got anything other than 100, okay? We have 100 ml of drug. That's it. That's all we're getting. Cool. So we need to find what amount of solution. Remember, we're adding some amount of not a drug to this 500 ml bottle. We're going to have a larger amount of 8% solution. So we're cutting it, we're diluting it, right? So it's going to be the same amount of drug, but more stuff that is not a drug in the bottle with it. So think of it in terms of like chocolate milk, right? You can use 2 teaspoons cocoa and just fill your mug halfway. You're going to have a very intensely chocolatey experience, right? You can take that same 2 teaspoons, right? And you could fill a whole pitcher. You can wrestle with the cardboard, a little kid in the school cafeteria. You can pour 2 whole things of milk, big old lemonade pitcher. That 2 whatever size spoons of cocoa. That's gonna be, you're gonna be having a milky time. All right? That's for maybe people that they're not really chocoholics. Right? Maybe full strength cocoa is a little too spicy for them. No judgment. So basically you want milk that's got like a little bit of color to it. Okay. Hint of cocoa. Well, it's the same amount of cocoa. It's the same amount of drug, but a much larger volume because a much lower percent. Good. Okay. All right. So we have figured out a lot. We have 100 ml of drug. We want that 100 ml of drug to be 8% of the amount of what we're looking for. This is the question they are asking. Literally, how much? When we get this, we're done. We did it. We can go home. Okay. How do we do that? We know this, and we know that it's going to be this percent of something, but how do we figure out something? This is where people get messed up because they're like, okay, so figuring out, 100 ml of drug because we had 500 ml of solution. The solution had 20% strength, so it's as easy as just doing 20% of 500. If I get 100 ml, doing it this way. That part's easy. But now we're getting into like scary math, right? Because now we're talking about we have 100 ml, and that's 8% of what? Like how do we, people might be thinking, okay, so I think we need to multiply something, but what do we multiply by what else? Or do we need to divide by something? And what do we divide into what else? Shh. Listen, babe, slow down. Slow down, be kind to yourself. Take slow, deep breaths and break it down into little steps, okay? Use what you know, all right? Use the way that you're even asking yourself a question. Have a conversation with yourself and have that mirror the way that you build your solutions to the problem, okay? So what you're gonna do is you're gonna say this unknown volume that we're trying to get to, but how much, right? Which is gonna be more than 500, but that's all we know, right? It's that big picture of not very chocolatey milk. We know that that is going to have 100 ml, be 8% of it. Did you hear how awkwardly that sentence was phrased? That's not how you would approach this logically, right? You're just asking yourself a question. What do we need to know? All right, well, 100 ml is 8% of what? Right? That's what we're trying to find. Remind me again, in writing equations, how do we write that something is a percent of something? The percent is a decimal with multiplication factor, right? How do we write 8%? Let's say 0.8. Oh, come on, don't disappoint me. Don't say 0.8. 0.08. Yes. Right. Remember? We're moving that decimal 2 spaces. And if there's an empty space there, that becomes a 0. Cool. Remember, right after the decimal is the 10th place, then the 100th place. 0.08. So it's mystery unknown volume number times 0.08. Okay, teach. We're right back where we started. We're at square one. Shows what you know. It's an unsolvable equation. Nobody can do that. Goodwill Hunting couldn't do it. We don't know what the next step is. Think about algebra. It's really easy. The rules are basically that this side of the equal sign has to be the same as this side. Okay? They mirror each other, and they have to equate, hence equation. So we have 100 over here, and whatever that is, times 0.08. And ultimately, we want to get this by itself, right? Because we want to have a number over here that is equal to itself. And if we know what the number is on this side, then we've solved it, because it's the same on both sides. Right? So we need to get this over here. But how do we throw something across an equal sign? Well, you invert the operation. Right? So we have 100. I'm going to do times 0.08. that's what's happening on this side. Now, we have to go through the looking glass into bizarro world, right? Jump across this equal sign, which has this power to warp and invert the operation that you're using. Going from multiplication to, you guessed it, division. Okay, now if you're not a very mathematically inclined person, you might think this is counterintuitive because you might think you're looking at this and saying, okay, we have big number, we're making it smaller. But we're dividing it. And we're dividing it by a very tiny number. We're going the wrong way. I think we should turn back, made a mistake somewhere. Nope. Stay the course. Have faith. Because what we're going to do, we can do long division. That can be another video, or we can just nod and say we did. We can do it like the proper way. You can just take out your calculator, all right? 100 divided by 0. Forget the 0. Get the 0. Remember, that's our writing 0. It's not our calculation. 100 divided by point. Put that point in there. 0. This 0 is important. That has to go in. 100 divided by 0.08. Begin. I think by now, even the slowest of calculators, meaning human calculator operators doing their calculations, should have had time to run their fingers across the keys, smash that equal sign, get a little something like that. Groovy. So, for extra credit, how much water, syrup, elixir, whatever, not a drug, diluent, are we adding to this original stock? Starting with this, we're ending with this. We're adding 750 ml of, we'll just call it water, to the original stock bottle of 20% solution to get 1,250. You don't believe me? This is the answer to the question they asked. Go ahead and plug it into the same equation rewritten. So what is the original question being asked? Right? We want an amount that 8% of it is 100 ml. Because we trust our work from that first step, right? Double check that. We know that 20% of 500 is 100. We're confident with that. What we really want to know, what the question is asking us to do, is determine how much solution, diluted solution, diluent combined with this, is going to give us 8% drug if it's got 100 milliliters of drug in it. Okay? Way that we do that, once we have our answer candidate, our proposed answer, is we take the answer, 1,250, multiply it by the multiplication factor of our desired percent expressed as a decimal, and it should come to under